What if the next New York wasn't on Earth? Not underwater, not in the desert, not floating in the sky, on the moon. It sounds like science fiction. But here's the pattern interrupt. Multiple space agencies are already building the roadmap to make it real. NASA's Artemis program aims to return humans to the moon this decade. China and Russia have announced plans for a joint international lunar research station in the 2030s. Private companies are developing lunar landers, habitats, and even 3D printed construction systems. So the real question isn't, is it crazy? The real question is, could the moon actually support human cities? Let's start with the harsh truth. The moon is brutally hostile. There is no breathable air, no liquid water flowing on the surface, no magnetic field to shield radiation. Temperatures swing from about 127 degrees Celsius in sunlight to minus 173 degrees Celsius at night. And a single lunar day lasts about 29.5 Earth days, meaning roughly 14 days of continuous daylight followed by 14 days of darkness. That's not inconvenient. That's deadly. Radiation alone is a deal breaker for unprotected humans. Data from NASA's Lunar Reconnaissance Orbiter shows radiation levels on the moon average around 1.3 millisieverts per day. On Earth, the average person receives about 2.4 millisieverts per year from natural background radiation. On the moon, you'd get roughly half of Earth's yearly dose in a single day. Stay exposed long enough, and the risks of cancer, central nervous system damage, and acute radiation sickness skyrocket. So should we just stop the conversation here? Not so fast. Because the moon also has something incredibly valuable: resources. In 2009, NASA's Lacrosse mission confirmed the presence of water ice in permanently shadowed craters near the lunar south pole. Subsequent missions, including India's Chandrayaan-1 and data from NASA's Sophia Airborne Observatory, strengthened the evidence that water exists on the moon, especially in cold, shadowed regions. Water changes everything. Water means drinking supplies. It means oxygen for breathing. It means hydrogen and oxygen for rocket fuel. In fact, splitting water into hydrogen and oxygen through electrolysis could allow the moon to become a refueling station for deep space missions. Because the moon's gravity is only 1/6 of Earth's, launching rockets from there requires far less energy. That's not just convenient. That's strategic. Now here's another surprise. Lunar soil, known as regolith, contains up to 40 to 45% oxygen by weight, chemically bound in minerals like silicon dioxide and metal oxides. Extracting that oxygen isn't easy, but laboratory experiments have already demonstrated it's technically possible. In theory, 1 metric ton of lunar regolith could yield hundreds of kilograms of oxygen. So while the moon has no breathable atmosphere, it has the ingredients to create one inside habitats. But let's address the biggest controversy: gravity. The moon's gravity is about 16.5% of Earth's. That might sound fun. You'd weigh less, jump higher, but long-term exposure to low gravity is a major unknown. On the International Space Station, astronauts experience bone density loss and muscle atrophy in microgravity. The moon's gravity is stronger than the ISS environment, but we still don't know if it's enough to maintain human health over years or decades. Could children develop normally in 1/6 gravity? Could the human cardiovascular system adapt permanently? We don't have the data yet, and that's why early lunar settlements will almost certainly begin as research bases, not cities. Now here's where things get interesting. Scientists are not planning to build glass domes on the surface like in old sci-fi movies. That would expose residents to radiation and micrometeorites. Instead, one leading concept is to build habitats underground or cover them with thick layers of regolith. Just a few meters of lunar soil could significantly reduce radiation exposure to safer levels. Some teams are even experimenting with 3D printing structures using simulated lunar regolith. The idea is simple. Don't bring building materials from Earth. Use what's already there. Because here's the economic reality. Launching 1 kilogram of material from Earth to the moon can cost tens of thousands of dollars, depending on the launch system. Even with reusable rockets reducing costs, it's still extremely expensive. A true lunar city would need to rely heavily on in-situ resource utilization, meaning mining, processing, and manufacturing directly on the moon. Energy is another challenge, but also an opportunity. Near the lunar South Pole, there are areas sometimes called peaks of near-eternal light, where sunlight can reach the surface for most of the year. These locations are prime candidates for solar power installations. During the long lunar night, energy storage systems or small nuclear reactors could provide backup power. NASA and other agencies are already investing in compact nuclear fission systems designed specifically for lunar use. Communication? Surprisingly manageable. The moon is about 384,400 kilometers away from Earth. Radio signals take about 1.3 seconds to travel one way. That means a 2.6-second round-trip delay. Noticeable, but completely workable. Compared to Mars, where delays can reach over 20 minutes one way, the moon is practically next door. So technically, could we build a city there? In principle, yes. But should we? Here's the controversy. Some critics argue that investing billions in lunar infrastructure is irresponsible when Earth faces climate change, poverty, and resource shortages. Why spend fortunes building habitats in one of the harshest environments imaginable? Supporters counter with a powerful argument. Space development drives innovation. Technologies developed for extreme environments often lead to breakthroughs in energy efficiency, water purification, recycling systems, and sustainable living, solutions that can directly benefit Earth. And there's another uncomfortable truth. Humanity is vulnerable. Asteroid impacts, supervolcanic eruptions, global pandemics. Our history proves that catastrophic events happen. Establishing self-sustaining settlements beyond Earth could act as a form of planetary backup, not as an escape plan for the wealthy, but as a long-term survival strategy for the species. But let's stay grounded. We are not talking about millions of people moving to the moon anytime soon. The first permanent lunar bases, if they happen in the coming decades, will likely house small crews, scientists, engineers, technicians. Think Antarctica research stations, not Manhattan. For a true city, we would need closed-loop life support systems that recycle air and water with extreme efficiency. We would need reliable local food production, possibly through hydroponics or controlled environment agriculture. We would need medical systems capable of handling emergencies without immediate evacuation to Earth. And perhaps most importantly, we would need a compelling economic reason to stay. Tourism? Possibly, though extraordinarily expensive. Scientific research? Absolutely. Mining rare materials like helium. 3 for potential future fusion energy? Still speculative, as commercial fusion power itself has not yet been achieved. So here's the honest answer. The moon could support human settlements, eventually, using current scientific principles and emerging technology. The physics allows it. The resources exist. The engineering pathways are being tested right now. But building a true, self-sustaining lunar city would be one of the most complex engineering challenges in human history. It would require international cooperation, long-term political commitment, and breakthroughs in life support sustainability. The moon is not a backup Earth. It is a hostile outpost that we could, with enormous effort, learn to survive on. And maybe that's the real reason this matters. Because learning how to live on the moon forces us to master recycling, efficiency, resilience, and cooperation at a level we've never achieved before. In trying to build a city out there, we might finally learn how to better protect the one we already have. If you're fascinated by where humanity is headed next, beyond borders, beyond oceans, beyond this planet, make sure you follow for more deep dives like this. Now let me ask you something. If we do build the first city on the moon, who should get to live there? And who decides?